Module 11, Lesson 3 covers generating multiple samples. Well, the pacing guide says this is going to be a 2-day lesson, but there's only 9 resources in it. They must be some pretty intense resources. You read that 30% of online gamers will pay to play them. You randomly select 50 gamers at your school to test this statistic. You found that 38% of the sample paid to play video games online. Your data showed that 38% of the students you surveyed pay to play online games. What are some steps you could take to determine how close each of these statistics might be to the overall population of the gaming? These are some of the things we'll be talking about in today's lesson. Our inquiry question says, how can taking multiple samples help you to make inferences about a population? And they give us a stack of books to look at. The most commonly used keyboard in the world is the QWERTY keyboard. That's the keyboard that is on your Apple devices that you use in my class or your Chromebooks. And the reason they call it QWERTY is if you look at the top of your keyboard where you have the Q and you follow the Q around, what comes next? W-E-R-T-Y, QWERTY. That's the reason it's called a QWERTY keyboard. However, there is another type of keyboard out there called the Dvorak. Okay, yeah, all right. The keyboard that is based on letter frequency. Think of all the words you read in English. Which vowel do you think occurs is going to be the most often, the least often? Suppose a random sample of 15 words is taken from the dictionary. How could you organize the occurrence of these vowels in the sample? This is what we're going to be looking at in this problem. The random sample taken from a dictionary is shown at the table. So you've got all these words here in table 1, and if you were to go through that, let's take and complete the frequency table for each vowel. So A, so I've got 1, I have 2, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Check our answers, and I missed an O in there. It looks like it should have been 6 O's. So that gave us a set of data, a random sample of each of these letters to find out how often they occurred. Now we're going to do it again because, you know, one sample, that's probably not enough to get a good base of all of our data. So let's do it again. And on this set of data, we found that A occurred 11 times, E occurred 13 times, I occurred 9 times, O occurred 8 times, and U occurred 8 times, and U occurred 2 times. That is a totally different set of information than we got with our first set of data. So now let's see what we get to do next. Now we're going to do the same thing a third time, and for your sake, I'm just going to take and get them to show us the answers here, save some time. This time, A only occurred 4 times. Last time I think it was 10. E occurred 12, I 5, O 8, and U 8. So now we have 3 different sets of data. And with that, you can see the table filled out showing each sample and the variations you got in your data in those samples. Now, despite that, even though there's variations, which vowel do you think occurred the most often? I'm thinking it's going to be E, because E had a very high number no matter which way we looked at it. You're going to use E a lot, so on that keyboard, you want that E to be a number or letter that's easy to reach. Now, find the average frequency of each vowel. That means you got to add them up and divide by the number of numbers. So I have 8 plus 11 is 19. 19 plus 3 is going to be 22, and 22 divided by the 3 is going to be 1.3. Excuse me, it's going to be 7.3. We'll just go ahead and show you what those answers are going to be as well, because, yep, they didn't tell us how you were, oh, they did say round nearest 10th, all right. So they added each one of these up. After they added them up, they divided by the number of numbers in their data set, and they found out that this is the average occurrence of each one of those letters in the word samples they collected. So based off of those averages, which vowel does occur the most often? It's going to be E, just like I said. Which one was the least used? That's going to be the U at 5.3. Surprisingly, O occurred more than I, and O occurred just as often as A did. I would have figured A would have been second place without any competition there. The mean calculated from a sample is called a sample mean. I don't think that'll be an actual vocab term, but we're going to highlight it anyhow. The sample mean is used to estimate the mean of a population. So you take several different samples, you average that sample, and you get the sample mean. It is important to understand that the sample mean is rarely equal to the population mean. So you're not likely to get the exact average of what you would have in the population. However, it's probably going to be pretty dang close if you conduct the sample properly. Moving on from here, if multiple samples are collected, it means that the samples can help you determine the reliability of the sample mean as an estimate of the population mean. Look for the place on the graph with the highest concentration of data values or where the points seem to pile up. The closer the sample to the sample mean are to this value, the better the estimates, to the sample mean are likely to provide. Next we're going to watch an animation and see what they have to say about doing just that.
Suppose you want to answer the statistical question, what is the length of a randomly selected word in a book? Start by generating a random sample. Count the number of letters in 10 randomly selected words on a randomly selected page of the book. Next, analyze the sample by finding the average number of letters in the 10 randomly selected words. How can you be sure that the results from this sample are representative of the length of words throughout the entire book? One way is to take multiple samples of the same type and size. Repeat the process to gather 100 samples representing 100 different pages from the book. Then find the average number of letters per word for each of the 100 samples. Next, display the data from the multiple samples using a dot plot. Place a dot at 5.3 to show the average word length of the first sample. Then graph the values for the remaining samples. Now you can make an inference about the average number of letters per word based on the shape of the distribution. The dot plot shows that the average length of the words in the book appears to be concentrated around 4.8 letters. Notice that the average from the first sample is greater than the averages from most of the other samples. Generating multiple samples more accurately represents the average length of a word in the book than the result of a single sample.
Well, that graph did a great job of showing us how you can actually visualize the data you're collecting and see where it's all going to clump up. It also showed that when we only had 10 samples given, the 10 words that they looked at, it did not give us nearly as accurate of a picture as it did when we had 100 words. Hopefully they're not going to make you all average 100 things, because that won't be a lot of fun. But the point of that is the more samples you take, that gives you the more data points going into your information, and the more data points you have going into your information, the more precise your answers are going to be. Now that leads us to a new vocabulary term, which is variability. Variability describes how the data vary within the sample or the set of samples. In other words, how close are all those data points going to be together? Taking multiple samples of the same sample size helps you to understand the variability among the samples. How can you see how far off your predictions might be had you only used 1 or 2 samples? The graph of multiple samples will only report the mean value in which the sample is as a single data point. However, the amount of variability in a data set can be informally described based on the visual distribution of the values on the graph as having high, low, or no variability. That was an awful lot of words, wasn't it? Let's see what they mean by that. Consider the distribution shown. Do you think that this distribution has a high, low, or no variability? I'm saying there is no variability because every single data point is right on the 15, which gives you very consistent data for sure. Recall that you learned about the mean absolute deviation in a previous grade. We also did that in, I think, the last lesson, and it was really, really ugly. The mean absolute deviation, which is a measure of variability, is the average distance each data value is from the mean of the samples. To find the mean absolute deviation, remember you first had to find the mean of the samples, and you add all those up. You divide by the number of samples, and what's that mean going to be? Well, that mean is going to end up being 75, and then you take it and say right there it's going to be a 75 as well. Check that. Whoa, wait a minute. I'm sorry, not 75, 25. I wasn't looking close enough. 20, well, back up again. 25. Try it again. Now we have happy little numbers there. And from here, the mean absolute deviation is going to be 0 because every single one of these data points here are 0 spaces away from that 25. So when you add up all those 0 spaces, divide it by 7, you get 0. So your mean absolute deviation is going to be 0. That means the distribution has no variability at all. You can visually see this on the graph because the data values do not vary. Now let's look at the distribution of this data set. We're going to call this distribution 2. And do you think this is going to have a high, low, or no variability among the samples? I'm thinking that's a pretty darn high variability because you go all the way from 5 up to 45. Nothing's really dominant in here. That's a pretty high variability here. And if you added all those numbers up and divided 300 by 12, let's just go ahead and do it this way. 300 divided by 12 ends up giving you 25. So that means that the mean of that data is also going to be 25. And 25 is located right here on our graph, which happens in this case to be the very middle of the graph. Next, if you wanted to find the mean absolute deviation, that meant you would have to find out how far each of these data points are from this mean of 25. The textbook was kind enough and they did that for us here. The reason you have 2 times 10 is because you had 2 data points that were 10 spaces away. You have 2 data points that were 0 spaces away. And over here you had 2 more data points that were 10 spaces away. And you could see those here, here, and here. That's the reason for the 2 times in there. And when you divide 120 by 12, that ends up giving you 10. And, hold on. All right, we got it booted back up and working again. So the mean we figured we find was 25. The mean absolute deviation is where we left off. 120 divided by 12 is 10. And that means your mean absolute deviation is also going to be 10. Now, the last mean absolute deviation we had was 0, and that showed there was no deviation. For this one, I'm thinking there's a pretty significant deviation. Since the distribution is greater than the mean absolute deviation, than the distribution, let's try this again. This distribution has a greater mean absolute deviation than the distribution in the first graph we looked at, number 1. 10 is greater than 0, so because remember we had mean absolute deviation of 10 in this one and 0 in the first one, so it has greater variability. And you can see this by simply looking at the graph and visually comparing your data sets, right? Now let's take a look at these 3 different distributions. We had distribution 1 and 2 we've already looked at, and distribution 3 is the new one they've added. It says consider distribution 3. Do you think this distribution has a greater variability among the samples than distribution 1? Absolutely it does, because distribution 1 had 0 variability. Its mean absolute deviation was 0. This one has a mean absolute deviation of 3, showing that it was an average of 3 spaces away from the median, or the mean. And how about sample 2? Well, it's going to be less variability than sample 2, because here you have 3 and here you have 10. This is where we're going to stop part 1 of this video, come back for part 2, and in part 2 we're going to start doing example 1, which is to analyze means of multiple samples. See you in part 2.